So I've been soldering wires and electronic components for over 20 years, and in this video I'm going to show you some tips and tricks that you can use as a beginner to learn how to solder as an absolute pro. So first of all, let's talk about soldering irons, wattages, temperature, all of those sort of things. So the iron that I use here, and let's just bring this in front of the camera down that I've got here. This is a Weller iron. This is an iron that I've used for quite a number of years. As you can see here on the front, it's just a basic power switch. The iron plugs straight into the base unit here. There's no temperature controlled at all on this iron. Now this is a 60 watt unit. This is my main iron. Now, if you have a look here, I do have a couple of tips, but this is the tip that I run most of the time. And you can undo this and swap out the tip that you want for a larger or finer tip. So as we talk about this, tips, you want to choose a tip that is going to be suited for your particular soldering that you're going to be doing. So if you're doing delicate soldering, you want a smaller, finer tip. If you're doing large wires or big amounts of soldering, then you want a thicker, larger tip. As far as wattage is concerned, a lot of people ask me, what wattage do I get? It depends on what kind of soldering you're going to be doing. If you're doing large wires or large DC connectors, then you might need quite a big iron, maybe 100 watts or more with a larger tip. But something like this little 60 watt thing, this will do for most things that you need to do. The wattage affects how long the heat can be transferred into the thing that you're soldering before it actually cools down too much that the solder just doesn't flow and we get dry joints or cold joints. Now I've also got another iron here as well. This is from JMM Solutions. This is another Australian product. This here is temperature controlled and it has a smaller tip on it. You can see here it's got a 3D printed case as well, but this has a much finer tip on it for more delicate soldering. But I actually have this for portable. So this actually plugs into a DeWalt battery, slips straight onto the top. You turn it on, gives you a very annoying beep, and you can adjust the temperature using this knob here. And you can see there I've got the set control set to 320 degrees. And being battery powered, again, portable, which is really good. And within sort of 10 seconds or so, we're already up to our temperature and we can start soldering. I'll put a link below in the description for a couple of irons that I think are very suitable for beginners, but you'll also need to pick up a holder for your iron and also, very importantly, a sponge, and I'll show you exactly why in a second. So let's dive straight in and have a look at some solder joints here. So if I bring over my PCB board that I showed here, this is actually a nano VNA common mode current choke rig. So I'll show you what a good solder joint looks like. If I actually turn this over here on the side, you'll see here on this connector that the solder flows quite naturally and nicely up the pin and then down onto the pad. So what we want to do is we want to avoid any balling or any solder that's not looking nice and shiny like this as well, and also anything that's not doesn't look like it's got a good connection here between the two joints. So you can see there that these joints are reasonably good. Now if I just flip it over here to some smaller solder pads there, you can see that similarly they all look reasonably good. And if you have a look at that one there, probably in the middle, actually now that I look at it, that one there's got more of a pillar type of thing, but it's still making a nice joint. It probably could use some reheating there, but all in all, most of those solder joints are pretty good. So what's the secret to getting joints looking like this? Well, the secret is heat, and I want to show you how to prepare your wires and also how to solder onto a PCB properly with a standard soldering iron. So what most people would do is they would twist these two wires together and then they would solder these. And there's nothing wrong with doing it that way. Sometimes though, we like to tin the wire. Now tinning the wire means preparing the wire before actually going and soldering it to something else. So for instance, if we wanted to solder to this Vero board here and we wanted to say solder it there, we would tin this wire first. So the first thing that we need to do is we need to make sure that our soldering iron is nice and clean. So I've got some solder here. If I just put that on the iron, you can see that that melts quite nicely. So we know that we're up to temperature. Now, just a caution too, you'll see that there is smoke coming off of that. Try not to breathe that in. You can use some extraction fans or extraction tool if you want to get that away. Sometimes it's not always possible, but you'll see there that we just tin the iron and we just use our sponge to just go into the sponge a few times so that it's nice and shiny and clean there on the edge of the iron, if you can see that. There's some little straggly bits there, but that's what we're trying to achieve. Now I'm just using normal 60-40 solder. This is 1mm diameter solder. It's got a little bit of flux in it too, and that's all that I use. So what I would do is I'd come in here into this joint, and then I would apply, I usually like to go from the bottom sometimes, but you can also go from the top. So we just put the iron there on the wire, and then we just flow our solder in. And it just takes a little bit of time. You have to hold the iron on whilst it flows. You'll see there, you'll notice how it's balling because I've put too much solder there onto the joint. And on the bottom, it's also not joined. So what we need to do is just flip it over. And again, it's all about heat and how long you actually hold the iron on for. So there's our completed join. Now you'll notice that I actually held the iron on for quite a bit of time, and these wires are actually quite hot, but you can see there the difference. So that is a good solder joint. It's probably not the cleanest because I've just been demonstrating it quickly here for the video, but you'll see that it has created a nice joint that's going to not have any issues in the future. Now, one thing that you'll notice too is that it did ball up, and I just left the iron on there a little bit longer until the solder managed to flow a bit better. Now, what happens if we want to go and put it onto our PCB? So I'm going to go and tin this wire. Now, tinning it again is putting a layer of solder over the top so that when we go and join this to something else, it makes it a lot easier and flows a lot better. So what I like to do is I get the wire here, and I'm going to now heat up the wire, but I'm also going to flow the solder onto the wire at the same time. So let's just see if we can get this into shot. So what I'm going to do is heat this solder up underneath so that it flows a little bit, and then I'm going to touch this onto the bottom of the wire, and then you can see there that I'm heating the wire, but I'm actually feeding the solder onto the wire, and you can twist it back and forth a little bit as you like until you get it tinned. If I want to solder it onto this strip, what I would do is I'd come in and I'd do the same thing. I would effectively flow some solder here onto that pad, just holding it there for a little bit. And we've got now some solder there, and then you can come in here with the wire, and you want to heat the two together. So effectively we want to do this. Remember, the key is heat, so sometimes that takes a little bit of time, and just got to wait for that to just cool down a little bit. So the key there is, again, it's just heat transfer between the two joints. Sometimes you'll get some wire that's oxidized. It makes it hard for the solder to flow onto it. So sometimes you need to clean up your wire if you don't have clean wire. So there we go. Now I've got two resistors in the board. You can see there, I've got the legs sticking out. Now what I would do is I wouldn't tin any of this first. I'd just put the components through the board like this. Sometimes you'll see that on some PCBs, they have like a silvery looking pad like this. These are already sort of pre-tinned, and they adhere and solder sticks to these very well. So in this case, I've just got a copper trace. That's a tinned copper trace there, or a tinned copper pad, which there's copper underneath this, and then it's got that tinning there on the top. So let's just go ahead and we'll solder this copper directly. So again, I'm going to apply heat to the copper and to the component there, and I'm just going to See how the solder flows? Now that's not a good joint. That's a very good demonstration here. So I took the iron off too quickly, and you'll see there, see how the solder has pulled around the joint and it hasn't adhered to this leg of this component. So what we do to fix that is, again, we just apply our iron onto the board, put a little bit more solder, and we just wait a little bit longer. And there we go. Now it's adhered to both. So sometimes you just need to check your joints as you're going along, but just holding for a little bit longer on the joint. There we go. But what I see all the time is people will do this and they'll dab. They'll dab because they don't want it to get too hot, and you'll end up not having a very good joint like that. You end up having a dry joint, you'll have all of this mess in here which you need to clean up later on. So holding on the iron for a longer period of time usually fixes those problems. The other thing I also see some people doing too is they'll put solder on the end of the iron like this, and then they'll try and paint it on like this onto the surface or the PCB or whatever they're trying to solder. Now as you can see, that doesn't work because you get this mess and it doesn't adhere properly. You can see there that I'm not doing this any heat to the pad. So you could see that at the end, it's just at the end of the iron there, it's just blobbed, it's just stuck, and it's not actually doing anything. So what we need to do is we need to come back, we need to clean our iron. That's the first thing. Again, in a good sponge, just a couple of swipes in the sponge, making sure that our iron is nice and clean. Then what we do is re-tin the iron again so that our solder sits on there nicely, and then sometimes I just like to clean it again, even after just doing that, just so that we've got a nice clean tip. There we go. And then come back in, and so we want to tin this again, hold the iron on there, add the solder, hold it, and wait till it flows. Now the other problem that I see is also when you're soldering to the board and you've either not tinned it or you're trying to add solder whilst you're trying to do that and you remove the wire too quickly. So let's just do, again, tinning this particular board, this particular piece of copper here on the board. There we go. Now if we come in with our wire and we go to solder this onto here, sometimes if we put on some heat on there and we solder it, you'll see there we go, it's starting to flow. But if we remove it too quickly and then we try to put it back on, that's not made a very good joint. It's joined, but mechanically it's not as good as if you were to flow and wait for that joint. And sometimes you need to have some Teflon hands, especially as I'm doing here, to just hold onto the wire long enough for it to flow. So there are some of my basic beginner soldering tips. Leave a comment below if this helped you or if you have additional tips for others to help them. Check out some of my other ham radio content over here, and I'll see you in the next video.